So here we are back with our broken formality test. And what I've done is I've changed the inputs a little bit. So let's run it on these new inputs. And what we can see is the function has now made a couple of mistakes. For example, it has indicated that 9 is prime, and it has indicated that 25 is prime. Whereas, of course, neither of those numbers is prime. So let's go back to the code and look at the mistake. The algorithm here is generally a valid one. It's fine to, first of all, special case the even numbers. And it's fine then to loop between 3 and the square root of the number. So the problem is that Python's range function doesn't loop through 3 and the square root of the input number. Rather, it loops between 3 and 1 less than the square root of the input number. So we can fix this, of course, easily by adding 1 to the square root, causing it to actually test against the full range that it needs to test in order to have a successful formality test. So let us run this code and see what happens. So 6 is not prime, 7 is. None of the rest of these numbers are prime, except for 29. So the question is, what happened here? Why did test coverage fail to identify the bug? And the answer is sort of simple. Statement coverage is a rather crude metric that only checks whether each statement executes once. Each statement executes at least once. That lets lots of bugs slip through. For example, we can have a statement execute, but it computes the wrong numerical answer. Or what happened here, a loop executed, but it executed for the wrong number of times, computing the wrong result. The lesson here is we should not let complete coverage plus a number of successful test cases fool us into thinking that a piece of code is right. It's often the case that deeper analysis is necessary.